right, so we're going to be using arc length formula to do a quick little application. So we have some hanging wire here, and it's a telephone wire, and we are centered at 0, so positive x's go this direction, negative x's go this direction, and we can use this Catenary equation to represent for this hanging wire that we have here. So a and c are our constants, x is our variable, and so again you plug in the x values, it gives us the height of our little wire here. So if I plug in 0, it would tell me the height at that point. Plug in 25, it tells me where it's attached to the pole. Plug in negative 25, it tells me where it's attached to the pole there. Those should be the same. All right, so first we have to do is find the length of the wire as a function of b. So we need to go from negative b to positive b. But an easier way to do this is we're going to go from 0 to b and then just double it. But first thing we have to do is find our derivative and then square it and then add 1 and then take the square root and then the integral. So let's start with just what y is. So y here is c plus a hyperbolic, so cosh x over a. And then now we do our derivative. So y prime would equal, and so c is a constant, so goodbye. And then we get a sinh x over a times derivative of the inside, which would be 1 over a. So this just gives us sinh x over, I wrote h, x over a. All right, next is we square it. So we get the square. And then next we put 1 plus. I'm already ahead of myself. Let's just do it. 1 plus, right? And then a square root. So there's our formula. We've done this enough that we can do this very quickly. All right, so we've plugged it all in. If you remember 1 plus hyperbolic sine squared, well, that would just be hyperbolic square of x over a. All right, and so that would just become cosh x over a. So now we need to do our integral. And so what I was saying before is instead of going from negative b to b, we can just go from 0 to b and double it. Because if we're going to find the arc length from here to here, well, from here to here is the same length from there to there. That's the center, right? So if we just double it, we can go from 0 to b cosh x over a dx. All right, and then the integral of cosh would be sinh, so 2 hyperbolic sine of x over a, but we do have to take care of that inside. So if I were to take the derivative of this, I would get 1 over a. So I need to put the reciprocal here. So I'll put the a here. And so then we take the derivative and check this. So derivative of sine of a hyperbolic sine sinh of x over a would be cosh of x over a, perfect, times 1 over a, and that a cancels with that a. There's no a there. Everything's good. B and 0. So now we just have to plug this in. So we end up with 2a of b over a minus 2a, I'm going to move this over, 0 over a. All right, and hyperbolic sine of 0, that's just going to be 1 minus 1 over 2, which is 0. So that's gone. That's 0. It's just 0. So then we end up with 2a b over a. So this is our S of b. So depending on where we want to place our b. So right now I have it at 25 here. So my b would be 25. It would tell me the arc length from here to here. If I plugged in 10, it would tell me the arc length from 0 to 10. Right? Okay. So let's circle that. We have the arc length as a function of b. Now we can apply it. Okay. So we really have two functions here. I'm going to write the other one down here just so that we have it. See, actually I already wrote it, huh? Let me just circle it as well, but in a different color so that we don't forget it. So we're going to be using both equations. We always do when we do applications. Not always, but most of the time. All right, so it says two poles are 50 feet apart. So that means negative 25, 25. Split. It says the length of the wire is 51 feet. So this is a 51-foot wire. If the lowest point of the wire must be 20 feet off the ground, okay, so we know at this point we would have 0, 20, that this is a, looks like a nose. I can't write them sideways with this pen. There we go. That's 20. Let's just use a length. From here to here is 20. There we go. Okay, how high up the pole should the wire be attached? Okay, so we want to know right here. So this is 25, comma, and then our y, right? So we're basically going to take and plug in 25 into our y value, and it'll tell us how high up it is, right? But we need a function here, right? Something that works. And our function here has a c and an a. So if I were to just plug 25 in there, I would end up with y equals c plus a cosh 25 over a. So this is not going to tell me my height because I don't know what c is and I don't know what a is, which means I'm going to be using that 51 and the 20. There's two pieces of info that are given to help me find my two variables that I'm missing. So we need two equations because we have two variables. Let's start with the first one. We know that the height here is 20. So if I were to plug 0 into this function, right, our normal function, I get y equals c plus a cosh x over a. I know my x is 0. Then I would get a y equals 20. So if I plug those in, I get 20 equals c plus a 0 over a. Well, hyperbolic cosine of 0 is 1. And so this is just c plus a equals 20. So let's put a little dotty thing around there. So that's equation number 1. That's number 1. Now we need a second equation. And so since I use this one, 99% chance we're going to be using this one for it. It says that our length is 51 feet. Yep, there it is. So that's our next equation. So 51 is equal to our arc length. So 2a b over a. So there's our equation. And so we can just plug this into our calculator and find out where they intersect, and that'll give us the value. But before we do that, I want to kind of give you an idea of what's going on with this catenary equation. So let's go to Desmos and take a look. Okay, so you can see I have the pole here, the poles, and the wire. And we have our catenary equation. And so we have the c and the a. That's all that's really in here that's affecting this, right? These are our constants. Let's see what they do. Well, we already knew that c will move it up and down because that's what that constant does. And what does a do? So you got to move the c and the a. The a changes the length, see, of the wire. So we just found something out. It's very happy. You can even make it into a smiley face now. But the whole point is that if we change the a, it changes the length. So the a is the one that's affecting our length with these fixed b values that we have. By the way, our b here is 25 because we're going from 0 to 25. So we will plug that one in as well. So c, it does not affect the arc length. It only affects our equation and how high up it is on the pole. So it is used, the c is used for the height of the pole. The a, however, is used for both. Look at this. It moves it up and down the pole, and it changes the arc length of the wire. So if you notice, this right here is our arc length. I've already got the formula just like we did before. There's our f of x. There's f prime squared square root 1 plus 0 to b of 2. Exactly what we did. C doesn't affect it. You can see our arc length does not change. Just the a does. And so you could sit here and keep moving it. All right, so now we're at 51, right? Keep moving it. Keep moving it. $72. All right. So 72 is going to be it because we hit 51, see? So 72, and you could just sit here and plug numbers in. So point, and then we do 9, too far, 8, too far, 7, too far, 6, too far, 4, too far, 3. So 3 is good, and we move on to the next one. 8 looks good, right? We should check 9, too far, 8. But you could just sit there and plug these in until you get stuff That works. So 5's too far, so it's got to be 4. And then the next one would be too far, 2. There it is. So there it is. 72.3842 is the length that we should have. And then you could just adjust this to what we need. So we know that our pole needs to have a height right there of 20. So that is our 20. 0, 20 is right there. You see it? All right. So then you could just move the C down. And then there is our matching 1. And if you think about it, these two had to add up to 20. So I could get in here and actually put in 0.3842. And now we should have exactly 20. See, right there. 0, 20 is our needed height. So there's our A and our C. So you could sit here and play with it until we get our cable to have a length of 51 and a height of 20. But we're going to be doing this mathematically in the same way. So what's the first thing I had to find? A. I had to find A in order to find C because I needed to find out what was my A that gave me a length of 51. So we're going to be doing the same thing. So we're going to take our B of 25 and we're going to plug it in. So we have 51 equals 2A hyperbolic sine 25 over A. Just like that. And so we can plug this in their calculator as a y1 and a y2, and we'll just make our A equal to x. So we do 51, and then our A will just make it into an x. So 2x. And then we've got to get our catalog open to get our hyperbolic. And then we need sine, so alpha and s. Sometimes you got to hit it twice. There we go. And we scroll down right there. Hyperbolic sine, and then 25 divided by x, just like that. So we have 2x, hyperbolic sine 25 over x. Now, for our window, we want to make sure that we include stuff that's there. So our x here is not our actual x for the problem. Our x is the a. So don't get those confused. We are not finding this x value. We are finding the a value right here. Okay, the x on this one right here is 25. The x here would be 0, but there's all these different x's that are going on in here. Okay, so let's do negative 100 to 100. If that's not enough, then we do more. We hit zoom 0 to fit it. And right here is going way up because we're getting those vertical asymptotes. So we go to our window and we go, okay, I don't need 2 million. How about, since we have a y-min of 50, we go to, I don't know, 100. And then hit graph. All right, and then you can see it did cross here. We have blue and then red, blue and then red. So that would be the left intersection point, and that would be the right intersection point. So second, calc, intersect, and then we go enter, right? Second curve, enter, and enter. There we go, enter. Had to be in the screen, and then enter. And it gives me, there's my 72.384 that we got in the calculator. So 72.384, and we'll do 3. Let's just do what it is. A equals 72.384. We'll use that. And then now that you found A, well, we can find C very, very quickly. C is just taking away 20. So we know that A plus C is equal to 20. So all you have to do is take the C and then the 20 and subtract the A. So this gives us negative 52.384. All right, now we have everything we need. So we found those two constants just like we were doing with the problem. So if you remember our little pole problem here, we first moved the A back and forth until we found the length of 51, and then we moved the C up and down until we found a needed height of 20. And that gave us the two numbers that we have here and here. But mathematically, we used our calculator to find A, and then we plugged the A back in to find C, and now we can plug them into our equation. So now y is equal to negative 52.384 plus 20 cosh And again, we're plugging in 25 because we want to find the height we want to find where the wire is connected to the pole at 25, because that's where the poles are located. So 25 over, and then our A again is 72. Why'd I plug in 20 there? I have no idea. Let's try that one again. Our A is 72.384. Cosh 25 over 72.384. And we plug this in our calculator, and it'll tell us exactly where on the pole it should be. And that gives us 24.36. And the units here are feet. So if we attach the wire that is 51, take a wire that's 51 feet, attach it at 24.36 and 24.36, it will hang and have a height right in the middle of 20 feet, which would clear everything. And you can see with our calculator here, with Desmos, just by playing around with it, we got the same thing. Okay, so there's our application. These are not, some are very, very simple. I tried to pick the hardest one for us so that you would have every little thing that you would need. So we find the arc length here, and then again we needed to find A first. So your C here is your last constant. You got to find that A first no matter what for this, because it's related to our arc length. We found the A, we plugged it back in to find the C, plugged them both in, and there we go.